So this is the third video on friction, and I call this one friction 3. So we want to deal with a body on an inclined plane. So let's assume first and foremost that this body is at rest. For a body at rest, what happens here? That is the first thing we want to do. For a body at rest, what is going to happen? All right. The major thing here is that number one, our frictional force is not equal to mu SR. It is not equal to mu SR. Our frictional force is not equal to mu SR. So what is going to happen? What is going to happen is just to assume that the body is at equilibrium, and as a result of that, F of S is equal to mg sine theta. Simple. Simple. That is simply what we are going to do. If you input some values, you want to play with some values, let theta be 30 degrees and let the mass be maybe 50 kg as well, and our g, which is acceleration due to gravity, to be 10 meter per seconds square. If a question like this is given, you will always want to be tempted to use this formula. You will always want to be what? Tempted to use what? To use this formula, which is not correct. You will be given mu s. You will be given mu s, let's say 0.5. You will be given, so that you will be tempted to use this formula. And of course, you know that your r is equal to our r here. Our r here is equal to mg cos theta. All of these things will be given to you so that you will be tempted to use another formula that is not correct. The correct formula to use here, if you are told that the body is at rest, this is the formula to use. F of S is equal to mg sine theta, and that will give you your frictional force. Okay, let's see what is going to happen. F of S will be equal to, what is the mass? 50 times g 10 sine 30 degrees, and that will give me 500 multiplied by 0.5, and that will be 250 Newton. That's all. That's all for this type of question. But in some cases, we have another type. Let me clean this so that we talk about the other type that we have. Okay, in another type, you will be told that the body is about to leave, is about to move. If the body is about to move, for a body to be about to move, we have F of S, which is equal to mg sine theta. Previous condition still holds. But another condition will now hold. And what's the other condition? The other condition is that F of S again is also equal to mu S R. Mu S R. But our R is mg cos theta. Our F of S will be mu S mg cos theta. So if I call this equation 1 and I call this equation 2, obviously what are we going to have? This is it, and this is also this. So what are we going to have? What we have is the equation of this with this. So I have mu S mg cos theta is equal to mg sine theta. Is equal to mg sine theta. In that case now, mu S is equal to mg sine theta over mg cos theta. This will cancel this, and we have mu S to be tan theta. So look at this very carefully. Look at it very carefully. One must be very careful in all this. So if the body is about to move, our mu S must be tan theta. The question must be given to you in such a way that your mu S will give you tan theta. So this is the major thing I want to discuss here under friction 3, that whenever the body is at rest, be very careful. Your frictional force is not equal to mu s times r. Rather, you use mg sin theta, which will give you what? Frictional force. Thank you for watching the video again. The video is directly from Tutorpedia Tutorial Center. We are located at Agbowo, very close to University of Ibadan. Thank you for watching. Don't always forget to subscribe. Please subscribe to this channel.